Let's explore the basics of HTML Scalable Vector Graphics, or SVG. These graphics are scalable vector graphics which we are going to explore in HTML. What exactly is SVG? SVG stands for Scalable Vector Graphics. It is an XML-based markup language for describing two-dimensional vector graphics. Because it is vector-based, SVG is resolution-independent, making it ideal for icons, logos, and illustrations. SVGs are supported by all modern browsers. Now let's look at the basic SVG structure. In HTML, the basic SVG element includes a width and height, and a viewbox attribute. The viewbox defines the coordinate system for the SVG content. Inside the SVG element, you can place various SVG shapes such as a circle with attributes like CX, Psi R, and Fill. Now let's delve into the basic SVG shapes. First, we have a circle. The circle element is defined by the CX and Psi attributes, which specify the center coordinates, and the R attribute, which defines the radius. The Fill attribute sets the color of the circle. Next, we have the rectangle. The rect element is defined by the X and Y attributes, specifying the top left corner coordinates, and the width and height attributes. The Fill attribute sets the color of the rectangle. Then we have line. The line element is defined by the X1, Y1, X2, and Y2 attributes, which specify the start and end points of the line. The stroke attribute sets the color of the line, and the stroke width attribute defines the thickness. Let us explore more SVG shapes. First, the polygon element. This is defined by the points attribute, which is a list of X, Y coordinate pairs, defining the vertices of the polygon. The Fill attribute sets the color. Then the ellipse element. This is defined by CX and Psi attributes, which specify the center coordinates, and the RX and Re attributes, which define the horizontal and vertical radii. The Fill attribute sets the color of the ellipse. Finally, the path element. This is defined by the D attribute, which contains path data, specifying the shape's outline. The Fill attribute sets the color of the path. SVG styling properties allow for precise control over the appearance of SVG elements. The Fill property sets the color inside a shape. The stroke property sets the color of the shape's outline. The stroke width property sets the width of the outline. The opacity property sets the transparency level of the entire element. The Fill opacity property sets transparency for the fill only. And the stroke opacity property sets the transparency for the stroke only. SVG gradients can add visual interest and depth to your graphics. There are two main types of gradients: linear gradients and radial gradients. A linear gradient transitions colors along a straight line. You define the gradient using the linear gradient element, specifying the start and end points with the X1, Y1, X2, and Y2 attributes. Within the linear gradient element, you add stop elements to define the colors and their positions. A radial gradient transitions colors from a central point outward. You define the gradient using the radial gradient element, specifying the center and radius with the CX, Psi, and R attributes. As with linear gradients, you use stop elements to define the colors and their positions. Text in SVG can be added using the text element. The X and Y attributes set the text position. The font family sets the typeface. The font size controls the text size. The text anchor sets the text alignment. And the dominant baseline controls vertical alignment. SVG transformations allow you to manipulate the position, size, and orientation of SVG elements. You can rotate elements using the rotate transform, specifying the angle and center point. You can scale elements using the scale transform, specifying the scaling factor. You can translate elements using the translate transform, specifying the horizontal and vertical shift. Finally, you can skew elements using the skew X transform to skew along the X-axis. SVG groups and reuse features help organize and optimize your SVG code. Use the G element to group SVG elements together. This allows you to apply transformations and styles to entire groups. Set common styles for grouped elements to ensure consistency. Use the DFS element to define reusable elements such as gradients or symbols. Then, use the use element to reuse the defined elements throughout your SVG. Let's quickly summarize the key benefits of SVG. SVGs are resolution independent, meaning they scale without any loss in quality. SVGs have small file sizes, at least for simple graphics. SVGs provide precise control over shapes and styling. SVGs are also accessible and SEO-friendly. And finally, SVGs allow direct integration with HTML and CSS. Some best practices include optimizing SVGs to reduce the file size, using ViewBox for responsive scaling, grouping related elements with the G element, using descriptive IDs and classes, and including a title and description for accessibility. If you're looking to learn more, check out the MDN web docs for comprehensive SVG documentation and tutorials. You might also want to check out some SVG editors, such as Inkscape, Adobe Illustrator, and Figma. Finally, there are a number of SVG libraries such as D3.js, SnapSVG, and SVG.js. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.